Hi guys, welcome back to Data Every Day. Today we're looking at a data set of online courses from Harvard and MIT from edX and trying to predict whether a given course will offer honor code certificates or not. So an honor code certificate is a certificate given just under the honor code. So there's no real proof that you completed the course fairly, but it's based on your honor. So let's try to predict this column based on the other 22 columns in here. Let's hop into the notebook and we will get started by importing NumPy and pandas for working with the data. For visualization, we'll use pyplot and Seaborn, and we'll build a scikit-learn pipeline today with a random forest classifier at the end. So we're going to need for that, we'll do train test split, and then for the pipeline we'll use the one-hot encoder, standard scaler, column transformer, and pipeline along with the classifier at the end. And then we will evaluate the model using the confusion matrix and classification report from sklearn. So go ahead and import all of that and load in the data using pandas.read.csv. I'm going to get the file path to the CSV file up here. Okay, and paste it in right here. We can take a look. So we have 23 columns. Some of these we're not going to use because a lot of them are sort of unique identifiers for a given example. For example, the course number and the course title, they're all going to be unique. Maybe some overlap, but that we don't need this to predict what we're looking for. I would also like to point out we have 290 rows, which is not fantastic. It's not a lot of data, so I'm not sure. There is also a bit of a class imbalance in this column. You can see most of our examples are positive, so they do have an honor code certificate, and a few of them are negative. So we probably are not going to get very good results in the negative class because of the class imbalance, but also because of the amount of data we have. So let's go ahead and start pre-processing. I'll get a little more information on the dataset with data.info just so we can see any missing values. And I don't see any missing values. The one thing I do notice is that we do have an object column here when we probably shouldn't. It seems like all the object columns are at the beginning, and those are the text columns here, and the date column. But then there's this one object column, %played video. If we go over there, that is here. This should be a float column. So the fact that it's object is a bit concerning. We're going to have to look into why that is. Alright, so let's start pre-processing now. I'm going to create a function called preprocessInputs that's going to take in a data frame, make a copy of it, and return the data frame. So all this does is duplicate the data frame. We'll store the processed version of our data into X, pass in data to our function to get that. So this is the copy that we'll do the pre-processing on. The first thing we can do here is drop unused columns. So like I said, some of these columns we're not going to need. We'll use df.drop for this. We just pass in the list of column names. Institution, this is just MIT or Harvard. I think that's valid to leave on. It's a binary variable, has two possible values. The course number, this I do want to drop because these are all unique, or I think there is some overlap in this dataset, but most of them are unique. So it's not really going to give us much useful information. Additionally, if we wanted to use it, we'd have to find some way, maybe with NLP, to encode these course numbers. The launch date, I definitely want to keep that on, but what we'll do is extract the year, month, and day features out of it and put them in their own columns. So I'll leave that there for now. Course title and instructors, I'm going to drop both of these. Course title because there's a little bit of overlap, but they're mainly unique. And the instructors, just because, so I guess we could do a multi-hot encode where we give each instructor its own column, and we separate by commas and send each instructor to its own column. But I'm not going to do that. I'm just going to drop it for today's video. So let's drop course title and instructors. We're dropping from axis 1, which is the column axis. And you can see we're now left with a more reasonable set of features. The only real object one left is course subject. Well, we do have institution. We're going to want to binary encode this and one-hot encode this because there's no ordering between the values in here. And I believe we have 4 unique values I checked before. Alright, but before we proceed, I want to figure out what's going on with this column because it's not supposed to be an object column. So we can always check to figure out what's wrong with it by trying to cast it to a float. We should get an error and it should tell us what the problem is. Alright, so there's this triple hyphen entry in this. I'm not sure how many there are, but what we can do is up here, fill missing values, and we take the column name, which is %played video, and we convert it to the same column, but with the replace function called. We replace any occurrences of a triple hyphen with a missing value, numpy.nan. And what we'll do after that is once those are replaced, we'll convert it to a float column. And then we will take the column and call .fillNA on it. And that allows us to fill the missing values with whatever we pass in. So let's pass in the mean of the column. So we'll fill the mean. And then let's set the original column equal to this now. Alright, now it did convert to a float properly. And if we check x.dtypes, you can see %played video is now a float column. So we're no more missing values, and I don't think there are any other missing values in this whole dataset. Alright, so now we don't want to do the encoding inside our preprocess inputs because we're going to do that in the pipeline. The advantage of using a pipeline is it allows you to pass human readable inputs into your model instead of trying to one-hot encode the inputs yourself and then pass them in. So I think we're pretty much done. The last thing I'd like to do is actually extract the date features. So technically we could use a function transformer to encode the date like this, and then within our pipeline do the extraction. Definitely possible. I'm just going to do it here though for simplicity. So we're going to extract date features, and we'll take the launch date column, and we'll use pandas.toDateTime to convert the column into a datetime column. The advantage of using a datetime column is you can access the year, month, and day as attributes of each object in the column. So we can take the launch year, and that will be the launch date, but with a function applied. That for every x, we get x.year. And that will, to each one of these dates, which is a given x, we just take x.year, which will return the year as an integer. We'll do the same thing for month. This is launch month. And we take x.month. And the same thing for day. This is launch day, and we take x.day. So once we've done that, we can drop the original launch date column since we took all the information we need out of it. So we'll drop it from axis 1. Alright, so launch date is gone, and at the end we have launch year, launch month, and launch day. So the last two categorical features are the ones we'll process in the pipeline. So what we'll do now is do our split. So we're going to split df into x and y, where y is what we're trying to predict. So that's the honor code certificates column right here. And x is the rest of the data, so we'll drop that column from axis 1. Then we'll do our train test split. So we'll send some portion of the data to the train set and the rest of it to the test set. That will generate xtrain, xtest, ytrain, and ytest. And for this we'll use the train test split function from scikit-learn. So we pass in x and y, specify a train size of, let's say, 70%. Keep shuffle equals true, so it'll shuffle the data before it makes the split. and then give it a random state so it will ensure that the shuffle is always done in the same way. And let's return these 4 sets of data over here and get them back over here. Alright, and we'll look at xtrain. Whoops. Alright. And let's see. ytrain as well. Ytrain is just the classes. So if we look at the value counts, we'll get the class distribution. And you can see we do have a class imbalance. So we're going to try to address this a little with class weights. But let's see how it goes. So now let's build the pipeline. Alright, so we want to one-hot encode these 2 columns, then scale the data, and then make predictions. So our model is going to look like this. It's going to be a pipeline whose steps are the following. We have a preprocessor, which will do the encoding for us, and a scaler, which will do the scaling for us, which will give each column the same range of values, and then a classifier. And we know what the classifier is. This is a random forest classifier, and we actually know what the scaler is as well, which is a standard scaler. Those are both from scikit-learn. For the preprocessor, we need to design this here. The preprocessor is going to be a column transformer, which is going to tell the model which columns to apply the one-hot encoding to. So transformers, okay, we need to actually create a transformer. So up here, we'll make our transformer, call it the one-hot transformer, and this is a pipeline itself, so it's like a sub-pipeline. In here, we create our one-hot transformer. That's going to be a one-hot encoder object from scikit-learn. I'm going to include sparse equals false in here, so that we don't get a sparse output. And drop equals if binary. So this is a nice little feature. When you're encoding a binary variable, you want to send one of the values to 0 and one of the values to 1. Now if we were to get the dummies for, let's look at xtrain sub institution, that sends the one value to 0, the other to 1, and you can see if we do a dummies one-hot encoding, then it's at each column is a inverse of the other, right? When we have a 0 in one, we have 1 in the other, and when we have 1 in one, we have a 0 in the other. So one of these columns is unnecessary. So in this case, you'd want to drop one of them to get an accurate encoding of the column. So what this does, drop if binary, is if we have a binary feature, it will drop one of the columns. That actually will take care of it for us. Alright, so now in here, let's create we'll call it a one-hot again. This will be our one-hot transformer. And this is where we specify which columns to apply it to. So let's apply it to those first 2 columns, which are institution and course subject. Alright, and I think we're ready. The last thing I want to do is just in here make sure we have remainder set to pass through. So that will ensure that the other columns that are not affected by the transformation will stay on the data frame when we pass it through. Actually, it will be converted to a NumPy array as it goes. Okay, so here's our model. Oh, we have a problem. Oh, we didn't actually pass. We didn't put this here. We had to put the preprocessor there, then we're good. Okay, now let's do training and just fit the model. Model.fit on the train set, xtrain, ytrain. Alright, it's done. So you can see it's doing the one-hot encoding, then the scaling, and then the classification. And let's get some results. So here we're going to get a set of predictions with we'll call ypred using model.predict on the test set. And then we'll also get the accuracy the accuracy we'll get from model.score on xtest, ytest. Then we'll generate a confusion matrix, which we imported from scikit-learn. Just pass in the real values and the predicted values. And let's also specify the order of labels so we know what we're dealing with. We'll put 0 first, 1 second. We'll also create a classification report. That's also from scikit-learn. We would pass in ytest and ypred. We'll also set the labels the same way. And we will include some target names, which allows us to give custom names to our labels. Let's give it negative and positive. Alright. Now let's just print it all out. First we'll print out the accuracy. We'll display it to 2 decimal places as a percentage and format this, format outside the quotes with ac times 100 so we see it as a percent. Then we'll plot the confusion matrix, so I'm making a new pie plot figure with a figure size of 6 by 6. And we'll use Seaborn's heat map function to plot the confusion matrix, turning on annotations, setting a format to G so that we see it as integers instead of scientific notation. Setting the minimum color value to 0, giving it a color map of blues, and turning off the color bar. Then we'll set some tick marks. So x ticks, we'll set the ticks, which is the spacing of the tick marks, to 0.5, 1.5, and then the labels for each tick mark will be the same as we have up here. So just copy that in. We'll do exactly the same thing for the y ticks, and then we'll give it some axis labels. So predicted on the x, and actual on the y. We'll also give a title, confusion matrix, and we'll show the output. Alright, and then the last thing I want to do is print out the classification report. Like so, and let's take a look. Alright, so here it is. We have a 96% accuracy, and we're actually doing better than I thought we would. You can see we have fairly good performance in both classes. It seems like our model is able to tell the difference between a non-honor certificate course and an honor certificate course, even though we have a class imbalance. You see we have 3 misclassifications, and that is we're falsely predicting negative examples as positive. So our prediction is positive when it was actually negative, so this would be a false positive. And that probably comes from the class imbalance. The model is more used to making predictions in the positive class. So let's see if we can make this even better by specifying a class weight in here. Class weight allows us to penalize one of the classes more than the other. We pass in a dictionary that maps a class weight to each class. By default, it is 1.0 for both. So if we want the model to pay more attention to the minority class, which it's having a harder time with, right now our model is putting more emphasis on the positive class. That's why we're seeing these 3 here. We want to try to shift some of those over here. Now, one of the problems with class weights is it also tends to shift some of these over. So let's see how this goes. Let's try making the negative class, which is our minority class, twice as important in the loss function, and then refit and redisplay. Alright, that actually made it go down. Look at that. See, we moved 1 more over into here, which is interesting. Let's try it with 3. And that's doing the opposite of what I'd expect, because this is very interesting. Maybe I have something wrong here. Because you see, the positive class is we're predicting more for the positive class when we're raising the weight for the negative. If we put this up to 10, you can see it's moving everything over here. What this is suggesting to me is that we have the wrong class labels or something. Yeah, that had the opposite effect. So actually, raising the other one up to 10 made our model better. We no longer have 3 misclassifications here. We end up having 1 misclassification here. And that actually is a really good model from the looks of it. I mean, we have very little data here, right? Our support as how many total training examples we have in the test set is very small, so it's hard to say how good this model would do with a larger set of data. But let's see if we can try to eliminate this 1 by lowering this a little, maybe to 5. No, that didn't work. What about 9? No, it looks like 10 is doing the best. Wait, oh. This is a random forest model, so there is some amount of randomness when we run this. We can give it a random state to ensure. Random state equals 1. This way we eliminate the randomness in it. And then let's try giving this big class weight. We're unable to get to the best performance we had. Weird, it's not really doing anything. Very interesting. I actually don't know why that is. Usually, by increasing the class weight for a given class, let's say we put 0 to 100 to 1000. This is saying the model is basically not caring about the positive class at all. It's going to make all its predictions in the negative class because it's being focused on 1000 times more than the positive. So if we run this, what's so interesting is it's not doing that. It's shifting its weight to the positive class. And the fact that it's doing this is making me think that the classes here are not the same as the classes here, like they're flipped. And I specified the labels here, which should give us the same ordering that we want. But it doesn't seem to be working. Alright, well, in any case, we do understand which is the negative class. Negative is minority here. The class with fewer examples. I don't know. Alright, in any case, you see the results. So that was today's video. Thank you so much for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.